Hello and welcome to your geometry recording. We are in week five, not five, we're in week 15. We are cruising along and we are actually going to start a new unit this week, which is also going to be the last unit that we're going to study this school year. So that's pretty exciting. You should have an idea of what this unit is all about because you took the Unit 8 pretest last week. But before we jump into this week's content and talk a little bit more about what Unit 8 is all about, I do want you to complete a warm-up problem in your math notebook. So if you don't have your math notebook out, go ahead and click pause and grab it. Remember, you do need to take notes as you watch this recording. You will turn the notes from this recording in with your week 15 notes to get full credit. All right, so for this math warm-up, you are going to multiply these two quantities. Multiply them times each other. Hint, you're going to use the distributive property. We're going to expand this by distributing. So go ahead and click pause and try this on your own. And when you're ready to check your work with mine, go ahead and click play. All right, so let's get out a different color here. We are going to distribute. So we're going to take this first term in our first set of parentheses, the x, and multiply it times the first term in the second set of parentheses, and we get x squared. Then we're going to do that again. We're going to take x and multiply it by the second term. And remember that -2 is attached to the x term. So that is going to become -2x. Then we're going to start all over with the second term in our first set of parentheses at 4. Multiply it by the first term in our second set of parentheses, get plus 4x. Do it again. 4 times that -2 is -8. Do we see any like terms that we can combine now? If you said yes, you are correct. You should. You should see that -2x and that positive 4x. When we add those together, we'll get a positive 2x. So when we combine our like terms, we still have this x squared out front. He's going to stay in the equation. Then we've got plus 2x, and then we've got the minus x. So that is what we get when we expand by multiplying two sets of parentheses. So terms in two sets of parentheses, remembering that we have to distribute. All right, so I'm going to go on to the next slide. So if you need more time, go ahead and click pause. All right, so as I mentioned, we are, heading into Unit 8 this week. So Unit 8 is all about measurement. We're going to look at two-dimensional shapes, three-dimensional shapes. We're going to look at finding area. We're going to look at, areas for two-dimensional shapes. Then when we move on to three-dimensional shapes, we're going to look at finding volume and surface area. So this week, we're going to mostly focus on two-dimensional shapes. In Unit 8, Session 1, we're going to look at areas of triangles and quadrilaterals, which I think that you will find you'll move through pretty quickly because you've seen this stuff before, right? And then Unit 8, Session 2, circles. You've already seen and learned about circles in probably several past math classes. What might be new, though, in Session 2 is when we start exploring polygons. So you might find that the polygon information in Session 2 is new. And then in Session 3, we're going to put together things that we've learned in Sessions 1 and 2, and we're going to create what we call composite figures. And composite figures are figures that include more than one shape. So it might be like a triangle combined with some type of quadrilateral like that. That would be a composite figure. And what we can do with composite figures is divide them into figures that we are familiar with. See that triangle and then a rectangle. and find the area of the figures that we're familiar with and then add those together. So in this session, this recording, we're going to focus more on session 1 and session 2 for time's sake. I always run out of time in these recordings. I don't want them to go too long. So Unit 8, Session 3, you're going to tackle more on your own, but once you have the foundations from 1 and 2, I think that you're going to find Session 3 pretty easy. So let's move right on in. I mentioned that we're going to be exploring the areas of triangles and parallelograms and other quadrilaterals, area of triangles and quadrilaterals. So before we learn those formulas to find area, I wanted to go over the term height because height is involved in finding the areas of triangles and other quadrilaterals. But what's important is that we remember when we find areas and we use the term height, or we measure the height, I should say, when we measure the height to use to find the areas, it's important that we know that the height has to form a right angle with the base. So whenever we have a figure, the height has to form a right angle with the base in order for it to be the height. So here we've got this quadrilateral, right? We've got this quadrilateral with 4 sides. The base is in red and then the other sides are in blue. The height would not be this side here or this side here. And the reason is because there's no right angle. So sometimes the height is not necessarily a side of one of our figures, and that's okay. As long as that height forms a right angle, we're good to go. So we can see over here we've got a triangle. The 2 sides are in blue and then the base is in red. And the height is actually outside if we draw in this imaginary line to show the height. We go from the vertex straight down to the base, and we have to form that 90-degree angle. So something to keep in mind as you start to go through your lessons in Unit 8 is that idea about the height, that it has to form a right angle with the base. All right, so let's take a look at that and now combine that with the formula to find area of triangles. Probably review, right? So the area of a triangle is 1/2 B times H. Okay, pretty easy formula, but what does B and H stand for? Aha. So this is what's important. It's super easy to Google formulas, and that's okay to do. But what's important is that when we find the formulas that we know and understand what those variables represent. So in this case, B, it's shown down here in the diagram, represents the base of the triangle. And then H represents the height. And remember, it's got to form that right angle with the base in order to be the height. So 1/2 base times height. So what I suggest that you do, multiply your base times your height and then divide that product by 2 or multiply it by 1/2. Same thing, but first do the multiplication before you divide by 2. Let's try an example here. So if you want, you can click pause. Remember, you're going to get so much more out of these sessions if you click pause and try things on your own. So I want you to find the area of this triangle. So click pause if you want to try it on your own because I'm about to do it. All right, so the first thing I always like to do is I like to write down my formula, just my general formula. Then I like to start substituting in my given values. So what's my base? So the base is from here to here, and that's 12. What is the height of the triangle? Is it 10? Is that my height? No, there's no right angle with the base. So that makes this length right here my height because it creates that right angle with the base. We just talked about that on the previous slide. So what I'm going to do first is I'm going to multiply 12 times 8. And I know 12 times 8 is 96. And then I'm going to divide 96 by 2. And when I do that, I get my area, which is 48. Is that my final answer? Would I get full credit for turning in an answer and saying that the area is 48? Nope, you would not. We need units of measurement. And since we're doing area, we know that it has to be inches squared. So when we're dealing with area, our units are going to be squared. Whichever units, if we're working with meters, inches, feet, it's got to be squared because we're multiplying. We're taking a base times the height. So inches times inches is inches squared. So the final answer would be 48 inches squared. So keep in mind when you find area, you're going to square your units. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, parallelograms. Again, something that's probably a review. To find the area, you take B times H, and remember, B equals base, the length of the base. H is that height, and it has to form a right angle with the base. That's very important, that right angle. So, a lot of times it's not going to be find the area. That's types of questions you guys have been doing in previous math classes. So now we can use the formula to help us find other parts. So let's take a look at this example. It says find the base, find the base of the parallelogram if the area, okay, area is 96 inches squared, so we're given the area, and the height is 8 inches. So in this case, we're given the height and the area, and we need to find the base, the length of the base. So if you want, you can go ahead and click pause now and try to answer this on your own. Get involved. The more you do, the more you practice, the better you're going to get at math. So go ahead and click pause, try this on your own, and then when you're ready to check your work with mine, go ahead and click play. So the first thing to do is simply write down what is the formula for the area of a parallelogram? Base times height. So now that we have that formula written down, let's substitute in the values given. The area was 96 inches squared. The height, we don't know the base, so we're going to put B in there, and the height is 8. So remember, these are being multiplied by each other. So to solve for B, to get B all alone, the opposite of multiplying is dividing. So I'm going to divide each side by 8. And I'm going to get the length of my base by taking 96 and dividing it by 8. And I get 12. Again, if I put 12 down as my answer, I would take off points. Don't forget units of measurement. And in this case, it was inches. So the base is going to be equal to 12 inches. Moving right along, I'm going to go to the next slide. So if you need more time, go ahead and click pause. We are then going to skip to rhombuses and kites. So these shapes should look familiar to you. We studied about different types of quadrilaterals earlier in the school year, but let's do a quick review. So rhombuses, all sides are congruent. That's what that tick tells us. Every side has one tick, so we know that all the sides are congruent. And then D1 and D2, do you remember what that means? Diagonal 1 and diagonal 2. So remember, diagonal is just when we draw in a line from, or it's the length, I shouldn't say we draw on a line. It's the length from one vertex to the opposite vertex, so that's a diagonal. Here's another diagonal from this vertex to the opposite vertex. So we need to know diagonals because diagonals are involved when we find the area of both rhombuses and kites. So to find the area of a rhombus, you're going to take 1/2 of the product of your two diagonals multiplied by each other. So again, multiply your diameter 1 times your, not your diameter, diagonal 1 times the length of your diagonal 2. Get that product when you multiply them together and then divide that by 2, and that's your area. Kite, very similar, right? The only difference, 4 sides, is that not all 4 sides are congruent, but these 2 sides are congruent, and then these 2 sides are congruent. And that's what makes it different from a rhombus, is not all sides are congruent, but we have 2 sets of congruent sides. Same formula to find the area though, 1/2 diagonal 1 times diagonal 2, the length of your 2 diagonals. I'm going to go on to the next slide, so make sure you have this written down in your math notebook. All right, so now that we know the area of kites and rhombuses are 1/2 diagonal 1 times diagonal 2, the length of our two diagonals. Let's use that to answer this problem. It says find the missing diagonal. So we're finding one of our D1s or D2s. Missing diagonal of a kite. It has an area of 112 square meters, and the other diagonal is 16 meters. So let's substitute in our known values into our formula. That's why I always like to start with just writing down what is the area of a kite. Now we have it written down, and it's easy for us to write in our given values. So the area is 112. Then we're going to take 1/2 times one of our diagonals is 16, and then we don't know the other. So I'm just going to put D for the other diagonal. So let's go ahead and do the math. 16 divided by 2 is 8. We're just cleaning up the right side of our equation. And now to solve for the diagonal, 8 times D. To undo that and get D all alone, we're going to divide each side by 8. And we get that the diagonal is 112 divided by 8 is 14. So the other length of our diagonal is 14. And what measure of units of measure are we using? Meters. So I would put 14 meters is the length of our other diagonal. So don't forget units of measurement. That's part of your answer. All right. You're going to look at pi in session 2. Dun, 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 you are introduced to circles, and pi is part of circles. So do you guys know how we find pi? Do you know how we get that number 3.14159 and it keeps going and going and going? It's an irrational number. It just keeps going. We usually round pi as 3.14, but do you know how we get that value? So pi is if you take the circumference of any circle and divide it by its diameter, you'll always get the value of pi. So circumference, the area along the outside, or the distance, I should say, the distance along the outside of a circle is the circumference. And if we divide the circumference of any circle by the diameter of the circle, you're going to get the value of pi. So I just wanted to share that to you because we use that term pi so much, but I want to make sure that we understand how we get that value. And then again, you're going to be learning to find the areas of circles. It's going to be review, so I'm not going to go in depth about it in this recording, but I do want to go more in depth in this recording about regular polygons. So a regular polygon, what does that mean? What does that mean? It means that it's a polygon where all sides are congruent and all the angles in your polygon are also congruent. So a polygon can have any number of sides. Triangle is a 3-sided polygon. 4 sides, so it can be some type of quadrilateral. You can have 5 sides, 6 sides, 7 sides, 8 sides, 9, 10, any number of sides to be a polygon. As long as all of our sides connect and we don't have any holes. And in order for it to be a regular polygon, all sides must be congruent and all angles must be congruent. So a square is an example of a regular polygon because all sides are congruent, and then we have all right angles, which means all of our angles are congruent. So that's what it means to be a regular polygon, and that's what we're going to focus on in session 2 is regular polygons. You're going to learn how to find the area of a polygon, but before you do that, I want to make sure you understand all the different parts of a regular polygon. So the center is what you think it is. It's located in the it's the equidistance from all sides is the center. The radius, same as it is for a circle, it's the distance from the center out to the side of your polygon. So the radius is the distance from the center to a side of your polygon. You can ignore those sides that look like a circle. Let me take those out. So I didn't want that to confuse you, so got rid of that. So our polygon here is a 1, 2, 3, 4, 5, 6-sided polygon. We've talked about the radius. It goes from our center out and touches, as long as it touches the side, it is the radius of the polygon. We can have radiuses just like circles. And then the apothem. The apothem is a very important part of our polygon. So write this down in your math notebook right now. Make sure you've got a diagram here that shows what a polygon, just draw in a polygon, and then we're going to talk about the apothem. So go ahead, draw in your math notebook right now. Any type of polygon, and then we're going to talk about the apothem. So notice the apothem here is drawn in red. So it's drawn in red. The radiuses are drawn in blue. The apothem is drawn in red. So what do you notice about this? It looks like a radius, right? Because it's drawn, and I'm going to stop myself here because I might have said something a little confusing. I want to make sure. So a radius is drawn in from the center to a vertex. So in order to be a radius, it can't just touch any side, and I want to clarify that right now before I go in because I think I might have kind of confused you. So a radius goes from the center to a vertex. So this is very important, center to a vertex. It can't just touch any side like a circle can. The radius of a polygon has to go from the center to a vertex. So we've got a couple different, we've only can draw on 1, 2, 3, 4, 5, 6 different radiuses here because it has to go from the center to a vertex. Now the apothem, look where it goes. And then notice this type of angle measurement it creates because that's important too. So the apothem goes from the center of the circle to, so it's a line segment that goes from the center of our circle to the midpoint of one of its sides. So to the midpoint of one of its sides. So midpoint meaning it's going to divide the side into 2 equal parts, and it must form a right angle with the side. So not only is it a midpoint to the side, which is important to know, but it also must form a right angle with the side. So again, apothem goes from the center out to the side, breaking it into that side into 2 equal parts because it intersects the side at the midpoint, and it also must form a right angle, and that's what an apothem is. You're going to need that to know what the apothem is to find the area of a regular polygon. So it's important that we know the parts of a regular polygon. Are you ready to move on? All right, here's the formula. The area of a regular polygon, and we'll stop after this, is 1/2 lowercase a, which represents the apothem, times uppercase P, which is the perimeter of the polygon. So make sure you understand what the lowercase a represents and the uppercase P represents in order to find the area of a regular polygon. Let's go ahead and find the area of this polygon, and then we're going to stop there. We're going to stop there. And you'll continue to explore as you go through the Schoology lessons this week. So go ahead and click pause, and if you want to try this one on your own first, I'd like you to do that. So go ahead and click pause, try to find the area of this polygon, and when you're ready to check your work with mine, go ahead and click play. So area of a polygon is one of a regular polygon. Remember, a regular polygon. All sides are congruent and all angles are congruent. So 1/2 lowercase p, the length of the apothem, times the perimeter of your polygon. So what is the apothem? Well, here's the distance from our center to our outside And there's that right angle, so we know that this is our apothem. So that's our apothem, which is our A in our lowercase a in our formula. And what's the perimeter? Well, we know the distance of one of the sides, the length, is 8 inches. There's 1, 2, 3, 4, 5 sides, so I know that the perimeter is going to be equal to 8 times 5, which is 40. So let's go ahead and plug those values into our formula. The apothem is 5.5. The perimeter is 40. So I'm going to multiply 5.5 times 40 first. 5.5 times 40, I get 220. Then I can take that value and divide it in half. And when I do that, I get 110. Again, we're finding the area, so our units must be squared. So area is 110 inches squared. You're going to go and take this more, more in depth this week in session 2, where you're given different parts. You're not necessarily going to be given straightforward the apothem and the perimeter. You're going to have to work a little bit harder to find the different parts. And you'll see that this week in Schoology. So make sure you take lots of good notes. And see here, you might have to find the length of the apothem. So that's a wrap. So let me know if you need any help this week. Let me put up your key phrase assignment. All right, so one of the things you learned about in this recording is the area for a regular polygon. And we learned how we can be given the area, such as the formula of a regular polygon is 1/2 a, lowercase a times capital P. But it's really important that we understand what the variables represent. So what I want you to tell me in the key phrase is, what does that lowercase a stand for? So first and foremost, what word does it represent? And then the second part is define that. So what does that part of the polygon A that is represented by A, what is that? Tell me what it is in the polygon. Like, how do you know what A is? Think of it as that. How do you know what A is when you're looking at the diagram of a regular polygon? And that's it. Have a great rest of your week and let me know if you need any help.